In this video, we're going to discuss sums, differences, products, and quotients of functions. So to find the sum of a function, we're basically just adding those two functions together. If we wanted to know the value of f plus g for a specific input, we're basically just finding the output from each function and adding them together. Similarly for differences and products and quotients, we're basically just taking those two outputs and doing the operation. So what we can do is we can actually get an equation for what that result is going to be instead of doing the operation every single time we want to know what the output would be for the combination of functions. So that's what we're going to practice in this video, and then we're also going to look at what the domain of each of these functions would be. For sums, differences, and products, it's pretty straightforward. Since we're inputting it into each function and then doing the operation, we basically need to just be able to input the value into both functions. So whatever the set of numbers is that belongs to both domains, that's the domain of f plus g, f minus g, and f times g. So to be in the domain of any of those combinations of functions, the number has to belong to both the domain of f and the domain of g, because if you can't plug it into one of the functions, then it's not going to be a valid input for the combination of functions. For f over g, we still have that criteria. The input has to belong to both original domains, but we also have to keep in mind that we can't divide by 0. And so if an input would make the output from g equal to 0, then we can't use that input for f over g. So here's an example. We have two functions. We have f of x equals square root of x plus 4, and we have g of x equals 2x minus 1. And so if we look at the domain of each of these functions, the domain of g is all real numbers. G is a polynomial. We can substitute any real number for x that we want because we're just going to multiply it by 2 and then subtract 1. So we will get a real number output every single time. So the domain of G is all real numbers. And then let's look at the domain of f. So f has a square root, which means we want to be careful that we don't end up with a negative number under the square root because we're only interested in real number outputs here. And so we need x plus 4 to be either positive or equal to 0. And so if we solve this inequality, that means that x has to be at least negative 4. So the domain of f is all numbers greater than or equal to negative 4. All right, so we're going to write down the sum, difference, product, and quotient of these functions, and we're going to consider the domain of each. So first let's look at f plus g of x. So the equation's not really the hard part here. You're going to take f and you're going to add g to it. And that's really all you have to do. There's no way to like simplify that or anything. We can't combine any terms because there aren't any like terms there. But what we're interested in is the domain of this function. So in order to substitute a number into this function, we have to be able to substitute it into f and into g, which kind of makes sense when we look at the equation. So the domain of g is all real numbers. There's no restriction coming from the function g, so we don't really have to worry about that in this case, but we do still have to worry about the domain of f because that was not all real numbers. We see here in the equation we're still going to be substituting something for x under that square root, and so we still need x to be at least negative 4. So that's going to be the domain here. All right, for f minus g, it's going to be very similar. we're going to take our function f and we're going to subtract the function g. We do want to make sure we're subtracting the entire function, so since it has two terms, we need parentheses there, which means we can do a little bit of simplifying this time. We can distribute in the negative. So there's our equation for f minus g. The domain, again, is going to be just the set of all numbers that are in both the domain of f and the domain of g. G has all reals, but f has that restriction. So we're looking at numbers greater than or equal to -4 for that domain as well. All right, let's look at f times g of x. So again, we're just doing the operation. We're taking the function f, multiplying it by the function g. You can just leave it like that. You can put g in front of f if you like, if you think that looks nicer. But there's really no need to do anything else with that. And the domain again is going to be all reals greater than or equal to -4 because the only restriction is coming from that square root function. Okay, and then for f over g, the equation is going to look like this. Now the domain is going to be a little bit different here. We still want x to be at least -4. We still can't plug anything in that's less than -4 because we would get a negative under the square root. But the extra thing we have to consider now is that we've divided, so we have a fraction. So we can't substitute in any x value that would make this denominator 0. We can't substitute in any x value that would make the output from g equal to 0. We could have an output of 0 here when the function g was by itself, but now it's in a denominator and we can't divide by 0. So I think it's helpful to draw this on a number line. So here's -4, -3, -2, -1, 0. All right, so from our function f, we already know that we have to use numbers that are greater than or equal to -4. So already we know we're restricted to this part of the number line. But now we also can't have a denominator of 0. So we can't have 2x plus 1 be equal to 0. So we need 2x plus 1 to not be 0. And if you subtract 1 and divide by 2, that means x cannot be equal to -1/2. So here's -1/2. We need to skip over that. We need to skip over that value. We can't include it in the domain of f over g. We still are only restricted to the right part, so we still can't use anything down here less than -4, but now we also have to skip over that value, -1/2. So we're going to need to use the union symbol to write this domain for f over g. So we still are starting at -4, but now we're going right up until -1/2. We're going to skip over it, so we need parentheses there. And then right after that value, we'll pick it up and then just follow it forever to the right. Here's another example. So we have f of x equals 1 over x minus 2 and g of x equals square root of x minus 1. So for the domain of f, you can substitute anything into f except you don't want a denominator of 0. We've talked about that before. So that means x can't be 2, which means you're basically graphing the whole number line except you're skipping over 2. Honestly, you don't probably need to write it in interval notation at this step. You just basically need to know, okay, it's all reals except -2, except +2 rather. For g of x, We have a square root. We want what's under the square root to be positive or 0, so x needs to be at least 1. So the domain of G is everything greater than or equal to 1. So for all of these functions that we're about to write down, the sum, the difference, the product, and the quotient of these, we can't use a value that doesn't belong to both domains. So if we graph this on the number line like we did before, so here's 0, here's 1, here's 2, here's 3. F specifies that we can't use 2. So we know we need to skip over that value of 2 because we can't substitute 2 into F. Now, just the domain of F was all reals except that, so we would shade the whole number line if we were just graphing the domain of F. But we can't use 0 now if we're combining with function G, because function G can only use values that are greater than or equal to 1. Now 2 was allowed in function G, but it's not allowed in function F. So if we look at the values that are allowable for both, it would look like this. We can only use numbers greater than or equal to 1, because that satisfies G, but we can't use 2 because that would not satisfy F. So for the sum, the product, and the quotient, that's going to be the domain. So for F plus G, which would be this function, the domain is going to be this set that we just graphed here. So 1 is included. We go right up until 2, but we skip over that, and then we go forever to the right. For F minus G, the equation is going to look something like this. And that's going to have the same domain. We still don't want to use 2 because it would make that denominator 0. We still have to use a number greater than or equal to 1 so that the square root works out. F times G, we're taking this fraction times this square root. You can think of that as square root of x minus 1 over 1, and then if you want to write it as one combined fraction, you can. Multiply the numerators, multiply the denominators. So all three of these functions have this domain because in all three cases we can't use 2 because we'd have a denominator problem, and we have to use numbers greater than or equal to 1, so we don't have a square root problem. Now for f over g, we still can't use anything outside of this domain, but we might have yet another restriction because we're dividing now. So if we look at f over g, okay, so I'm going to write this literally, f over g, but that's not super helpful. So it might be helpful to think about that dividing by something is the same as multiplying by its reciprocal. So dividing by square root of x minus 1 is the same as multiplying by 1 over square root of x minus 1. And so we can write the function rule like this. Now the only difference between the domain of this function and the others is that now the square root's in the denominator, which means now if we substitute 1 for x, we'll have a denominator of 0. So we're still restricted to this, but now we're further restricting, and now we can't use 1. We could use 1 here, here, and here because the square root was in the numerator. But now that the square root's in the denominator, we can't use 1 anymore, so we need parentheses at that end, but that's the only difference. Because we need x to not be equal to 1. All right, here we have two polynomials. We don't have a denominator to worry about. We don't have a root to worry about. So the domain for both of these is all real numbers. So the domain of f is all real numbers, and the domain of g is all real numbers as well. So when we add, subtract, or multiply these functions, we're not going to have any sort of restriction on the domain. We're still going to be able to use all real numbers. When we write down the equation of f plus g, we're just writing down f and then adding g. So then you can combine some like terms there. We have a plus 3x and a plus x, and we have a minus 6 and a minus 2. For f minus g, we'll write down f, and then we saw this in another example. We have two terms in that function g, so we want to make sure that both terms get subtracted. So we're going to need parentheses there, and then we can distribute in the subtraction. So minus x plus 2, and then just like in the first one, we can combine some like terms there. So we have 3x minus x, and we have negative 6 plus 2. F times g is going to look like this. So we can expand that out by multiplying the x times every term in the first set of parentheses, and then doing the same with the negative 2. I'm going to start with the x though, so x to the fourth minus 2x cubed plus 3x squared minus 6x. And then I'm going to distribute the negative 2. So minus 2x cubed plus 4x squared minus 6x plus 12. And then we can combine some like terms. Okay, just like we've seen before, all three of these functions have the same domain. It's just whatever the two original domains have in common. In this case, they were both all real numbers. All of these resulting functions are polynomials as well. Any polynomial has a domain of all real numbers. Now for f divided by g, there is going to be a restriction because now we're dividing by something and we don't want to have a denominator of 0. So here we're taking this divided by x minus 2. So right away we can see the denominator here is x minus 2, which means x cannot be 2. So the domain of this is all reals except 2. Now you can simplify this, you just want to do it carefully. The numerator factors as x minus 2 times x squared plus 3. And so it looks like then, okay, these divide out, right? But since this is coming from doing f over g, we want to still make a note that x can't be 2. So you can simplify this as long as you specify then that x cannot be 2. Because without that, it looks like you can substitute in anything since it looks like it results in a polynomial. All right, we're going to do one more example here. We have 1 over x minus 2 for our function f. We've seen this one before. That's going to be all reals except 2 for the domain. And then for G, x can't be 3. So domain's going to be all reals except -3. All right, so when we're writing down the equation for f plus g and for f minus g, there's not really a whole lot to do. There's f plus g, and here's f minus g. You could get a common denominator and do the addition or subtraction if you want, but it's not really necessary for our purposes. F times g is going to look like this. And so you could do that multiplication. That's not too terrible. You do 1 times 2x on the top, and then x minus 2 times x plus 3 on the bottom. I would leave that denominator factored because it's going to be helpful for everything else we're about to do. Because now we want to consider the domain of these. So the domain of these, if you look at each one, you can't use 2 and you can't use -3 now for the denominator. So it's all reals except skipping over -3 and 2. So the domain's going to be written like this in interval notation. And then for f over g, again, it's kind of messy to leave it like this. It's a helpful starting point because you can see, all right, I still don't want x to be 2 and I still don't want x to be -3. It's always the case for f over g that you're at least restricted to what you were restricted to for the first 3. You still want only numbers that you can substitute into both functions. If you want to simplify this a bit, we're going to think again, like we did earlier, that dividing by a fraction is the same as multiplying by its reciprocal. And so it kind of looks like this is what we end up with. But again, we want to keep in mind where this came from. This came from this division here. And so we want to make a note that x can't be -3. Because that's not obvious from this denominator, right? With this denominator, we can see that x is not equal to 2. And now we also don't want x to be 0. But it's not obvious from the equation that x can't be -3. So this is how we would write the simplified version. We would include that specification that x can't be -3. It's obvious from the equation that x can't be 0 or 2, so we don't really need to state that. When we're asked for the domain, though, we do need to think about the fact that we can't use now 0 or 2 or -3. And so we have 3 numbers now that we're skipping on the number line. So we're going to need an extra interval to write down this domain. So -infinity to -3, -3 to 0, 0 to 2, and 2 to infinity.